Have you ever wondered how software is actually built? Whether it's a small script or a full-fledged application, every software follows a structured development process. Today, we're diving into the software development process, an essential concept for understanding how programs go from an idea to a fully functional product. Hey everyone, welcome back to the Tech Tutor, where we simplify computer science topics. This video is the first of my data structures and algorithms in C++ playlist, and today we'll be breaking down the software development lifecycle, an important process for anyone learning to code or build applications. Okay, so coming to what the software development actually is. So software development, right, it's more than just writing code. It's a structured approach to solving problems efficiently. Every software, from mobile apps to websites, goes through multiple phases before it reaches the user. So why should we care? Because understanding this process will help us write better, more scalable code and avoid common pitfalls. Okay, now let's have a look at the 6 major phases of software development. So, coming to the 6 major development phases, first we have the requirement analysis, then we have design, then we have the implementation, then we have testing, then we have deployment, and lastly we have maintenance. Each of these plays a crucial role in ensuring that the final product is functional, reliable, and efficient. Let's go through each of them one by one. Coming to the first phase, the requirement analysis phase. The first step in building software is understanding the problem you are solving. We should know the problem that we're solving. This is called requirement analysis. So some key tasks in this phase: identify user needs, define your functional and non-functional requirements, and gather input from your stakeholders. For example, let's say we're building a food tracking app. We need to decide, should the app allow barcodes scanning? Should it track macronutrients? How will users input data? So these types of questions help define what the final product should look like and what we would require. Okay? Now coming to the software design, once we have the requirements, the next step is designing the software structure. This includes choosing the right architecture, for example, monolithic versus microservices, selecting appropriate algorithms, data structures and algorithms, creating visual representations, UML diagrams, flowcharts. For example, in our food tracking app, if we need to look up fast looks up of previous logged meals, right? We could use a hash. We have some options. Should we use a hash map or a linked list? These decisions really will impact our performance for our application. Coming to phase 3. Now we actually start coding. This phase involves writing clean modular code, using version control, using Git or GitHub, and following best coding practices. For example, if we're implementing a priority queue using a binary heap, we need to decide whether to use a min heap or max heap, depending on how we want elements to be processed. Now coming to our next phase, testing phase. Before launching, we need to test our code to catch bugs and ensure it works correctly. There are several types of testing. Coming to the first type, we have unit testing. Unit testing is testing individual functions or classes. Okay? Then we have integration testing, ensuring different modules work together. Okay? System testing, checking the full application. Okay? And performance testing, evaluating speed and scalability of the application. For example, if we built a binary search tree, we might write unit tests to check if insertions, deletions, and traversals work correctly. Okay? Now, coming to phase 5. This is where, after we're done with our testing, it's time to deploy the software so users can access it. This can involve deploying to servers or app stores, setting up CI/CD pipelines for automated releases, monitoring for issues in production. For example, if we developed a React Native app, we might deploy it to both the Google Play Store and the Apple App Store, right? So ensuring smooth installation and updates is what we do in this phase. Coming to the next phase, maintenance and updates. So software, it doesn't end at deployment. Maintenance ensures the product stays functional and up to date. Bug fixes and security patches, performance optimization, feature enhancement, right? For instance, if our food tracking app receives feedback that the barcode scanner is too slow, we might need to optimize the image processing algorithm. Okay? Now coming to some development models that we could use in our software development process, we have something known as agile development and waterfall. So what the waterfall model is, it's a structural and sequential process. The agile methodology, however, it's a flexible iterative approach. Okay, it's an iterative approach. So most modern teams, they use agile, where developers work in short sprints and continuously improve the software based on user feedback. This is especially useful for fast changing projects like mobile apps. Okay, now you might be wondering, what is the role of data structures and algorithms in development? So efficient software depends on choosing the right data structures and algorithms. For example, sorting algorithms, they're used where? Used in database indexing. Graphs, we see them used in Google Maps for route optimization. Hashing, it's used in password authentication systems. So understanding how these work would significantly improve your coding skills and help you write more efficient programs. Okay, now coming to some best practices for software development. Here are some things that we need to know. Use version control to track code changes. Follow coding standards for readability. Optimize data structures and algorithms for efficiency. Write clean, modular code and test thoroughly before deployment. So by sticking to these principles, you'll write better, more maintainable software. So coming to the key takeaways, let's recap what we kind of went through today. So software development process follows structured phases. Choosing the right data structures matters. Agile development is the standard in modern software engineering. Testing is crucial for reliability. Maintenance ensures long-term success. So if you understand these fundamentals, you're already ahead in your software development journey. Thank you so much, guys. If you did like our first video of our data structures and algorithms course, please do like, share, and subscribe. If you have any comments and suggestions, please leave them down in the comment section below. Thank you so much. I'll see you in the next video. Bye bye.